Welcome to Institute of Aeronautical Engineering video lectures, and this is Professor VVSH Prasad, Department of Mechanical Engineering, and today's topic is on friction clutches, which is the part of dynamics of machinery in the theory of machines. And the course outcomes that will be met from this topic will be in the course outcome 4, applying the laws of friction on clutches, brakes, and dynamometers to reduce the power losses for the effective torque transmission. Further to this, a clutch is a device used to transmit the rotary motion of one shaft to another when desired. The axes of two shafts are coincident. In friction clutches, the connection of the engine shaft to the gearbox shaft is affected by friction between two or more rotating concentric surfaces. The surfaces can be pressed firmly against one another when engaged, and clutch tends to rotate as a single unit. And we can see from the given diagram, the clutch is considered to be the having in an automobile, particularly we'll using the clutches. The power transmission takes place from the when you make block diagrams, engine to gearbox to propeller. So engine to gearbox, here you are going to have the clutches. Clutch engagement and disengagement will take place, and because of this clutch engagement and disengagement, the speed variations are accomplished from the gearbox. Therefore, the engine formulates the input shaft, and gearbox output shaft is going to be the output shaft. From here, it goes to the propeller shaft. Here, basically, in a disc clutch or single plate clutch, the clutch is inserted in the flywheel mechanism, where we have got a flywheel mounted on the input shaft, and there is a inside there is going to be a clutch plate and friction lining, and this is a splined hub. Because of this splined hub, by hand actuation, the the clutch plate can be moved forward and backward, and the clutch plate and the friction lining are kept in contact by using a spring pressure, and the whole mechanism is done through a pressure plate, and the splined plate hub will be used for after disengagement. When you wanted to change the speed, the friction lining, along with the friction lining, the direction is for a higher speed or lower speed, the motion, the engagement, the movement of the gearbox will take place. Once the gear is engaged, then the clutch is put into the engagement, and this is done by virtue of the a single plate or multi plate clutches. The friction lining materials will be mostly ferrodo, which will provide the highest coefficient of friction, unlike the other materials of metallic in nature. But uh, when it comes to the materials, definitely the friction plays an important role. The friction is considered as a foil in case of bearings. When it comes to a friction is considered as a friend in case of three areas. All the three areas are considered to be the clutch, then dynamometer, and brakes. So at these areas, we consider this to be uh, phi in means where the friction is not an acceptable criteria in bearings because power will be lost. As a friend, friction is considered for clutches, dynamometers, and brakes. So when it comes to the clutch, whether either is for a bearing or a clutch, the derivation concepts are one and the same. Pivot collars, or it is considered to be a single plate clutch similar to that. Pivot collars, and when a rotating shaft is subjected to an axial load, the thrust, that is axial force, is taken either by pivot or collar. For examples, the shaft of a steam turbine and propeller shaft of a ship. See, the vertical thrust, that is the load in a vertical uh, hydro turbine, the whole weight of the turbine itself constitutes a major contributor for the thrust load, and it can be considered as the a collar containing the inner radius Ri, outer radius R outer, and for our derivation purpose we are going to consider a delta r, a small portion at a radius r. This is the point which you have to keep it in understanding. Then collar bearing, or the derivation can be extended to a single plate clutch. So a collar bearing, or simply a collar, is provided at any position along the shaft and bears the axial load on a mating surface. The surface of the collar may be plain, normal to the shaft, or of the conical shape. When you see, we have got a single plate clutch, or it can be a cone clutch, or a single plate collar, or a conical collar. So when we call it as collars or pivots in case of bearings. In case of clutches, we call them as the single plate clutch or cone clutch. Pivot bearing. When the axial load is taken by end of the shaft, which is inserted in a recess to bear the thrust, it is called pivot bearing or simply a pivot. It is also known as footstep bearing, where footstep bearing is understood very well in the machine drawing. In the machine drawing, we have read very clearly about a pivot bearing or a footstep bearing which will take the vertical load. And here, single blade clutch without any recess having a radius r. When it comes to a conical clutch, the include angle is 2 alpha, where alpha is equal to single cone angle. Okay, wherein the radius is also r. So while we derive the clutches or bearings, what is the frictional torque that is to be deduced? For finding out the frictional torque, there are two theories that are available. That the two theories which include, one is uniform pressure theory, other one is uniform wear theory. Friction torque of a collar or a pivot or a clutch is calculated usually on the basis of two assumptions. Each assumption leads to a different value of torque. In one case, it is assumed that intensity of pressure on the bearing surface is constant, where in the second, the first one is under uniform pressure, the pressure is constant. Under uniform wear, it is uniform wearing of the bearing surface or clutch surface. Under the first assumption, pressure is assumed to be uniform over the surface area and the intensity of pressure is given as axial force by cross-sectional area, where axial force is F and the pressure intensity F is equal to F by pi into R naught square minus R internal square. This is the cross-sectional area. I think this is the pressure intensity that will be there between the journal and the bearing or a clutch and clutch plate. It is assumed the pressure is uniform throughout its life. Then the second theory is uniform wear. For uniform wear over an area, the intensity of pressure should be very inversely proportional to the elementary areas. That is, it should decrease with the increase of the elementary area and vice versa. This can be illustrated by drawing a line with a chalk. In doing so, a little quantity of chalk is worn from the stick. Now, if it is desired that the chalk is worn by same amount, but the length of the line is doubled, the pressure on the chalk has to be reduced to half that in the previous case. Therefore, in case of uniform wear, the product of pressure applied and the distance traveled must be constant. For uniform wear of the surface, let if you consider two areas in a collar clutch or a single plate clutch or a uniform bearing, P1 normal pressure between two surfaces at radius R1, small r1. If you consider two areas, say at one point it is R1, at other point it is R2. If you consider, then where P1 is the normal pressure between two surfaces. This surfaces. What is our assumption? P2 is the normal pressure between two surfaces at R2. B is the width of the surface at radii R1 and R2 equal width. Therefore, P1 into area at R1 is equal to P2 into area at R2. Okay. So then what is the projected area if you consider? P1 into 2 pi R1 into B. That is the projected area. So the projected area considered to be like that. 2 pi R1 into B. In the second case, 2 pi R2 into B. B is constant. But the area is different in both the cases because of the radius consideration. If you look at, and we assume that it is a uniform wear at both the areas. Therefore, P1 into 2 pi R1 into B is equal to P2 into 2 pi R2 into B. Cancelling 2 pi and B and B. Therefore, P1 R1 is equal to P2 R2 and we can conclude that P into R is equal to constant and we write that under uniform wear criteria P into R is equal to constant and where C is called wear rate or uniform wear. That is the wherein what is constant in uniform pressure? Under uniform pressure P is constant, pressure intensity is constant. But in case of uniform wear, the P into R is a constant one. So further to this, our pressure intensity P at radius R of the collar is equal to P is equal to load by area F by 2 pi R into R naught minus Ri. In a flat pivot in which R internal is equal to 0, the pressure would be infinity at the center of the bearing, which cannot be true. Thus, there is a flaw or there is a uniform wear theory has got a deviation in assumption. But we consider that as we progress into the subject, we can understand that uniform wear theory has to be applied in clutches and dynamometers. And the derivation, flat collar, or we can say single plate clutch. Single plate clutch. Let P is equal to uniform normal pressure over the area. F is equal to axial thrust. F is equal to axial thrust. Then N is the rotation speed of the shaft, and where coefficient of friction between these collar as well as the hub is mu. Coefficient of friction to surfaces. Consider an elemental width of delta r of the collars at radius r. The frictional force on the element can be considered as delta F is equal to mu into axial force. What is axial force? Axial force F is equal to P into cross-sectional area. P into cross-sectional area. Therefore, mu into A, P into area of the element, 2 pi r delta r. Please, that is the projected area, 2 pi r into delta. That is the projected area we are going to consider. Friction torque about the axis of the shaft, that is nothing but frictional force into distance. Frictional force into distance. That is nothing but the frictional force will be acting here at a radius small r. That is dou phi into r. Okay. That is mu into P into 2 pi r delta r into r. Okay. Then r and r becomes r square, 2 mu p pi r square delta r. Therefore, total frictional torque is given as T is equal to r internal to r outer, 2 mu p pi r square dr, integrating over the internal radius to external radius. Then this is the elemental frictional torque derivation we have concluded, where this P we are going to substitute as a uniform pressure and uniform wear, and we will try to find out the total frictional torque in both the cases. Further, using with uniform pressure theory, the pressure is uniform over the whole area and is given by, as we have proved here, P is equal to F by pi r naught square minus r internal square. Therefore, the total torque is given as r internal to r outer, 2 mu pi r square F by pi r naught square minus r internal square into dr. Therefore, 2 mu F r naught square minus r internal square into r square dr. Therefore, after integrating, r square dr will become r cube by 3. Substituting ri and r naught in this, 2 mu f r naught cube minus r internal cube by 3 r naught square minus r internal square outer minus r internal square. This is the total friction torque that is transmitted when we consider about the uniform pressure theory. Uniform pressure theory. Further, in the many of the numerals, it may be considered as the cubic term, and this is the square term. The So this can be meter cube by meter square. It will be equated to meters. Therefore, sometimes in the tutorials, instead of giving internal diameter or outer diameter of the clutch, some questions will be given as the mean diameter. Therefore, this can be reduced to 2/3 mu f or mean as per the tutorials when you go ahead. That is equal to total torque. Further to that, the same if we consider based on the uniform wear theory. Therefore, we have derived where pressure intensity F is given as F by 2 pi R naught minus R internal, as we have done under uniform wear theory. Then the total torque 2 mu pi R square into where you have to consider F by 2 pi R naught minus R internal, R outer minus R internal into dr. Here we can consider that 2 pi and this R goes R times and mu F R by R naught minus R outer minus R internal into dr. Therefore, it is an integration only R dr. Then it becomes, the integral value become R square by 2. R square by 2 and you have to substitute R outer, R internal. When you substitute, then it becomes 2 mu f R outer square minus R internal by 2 into R naught R outer minus R internal. Therefore, if this can be written as A square minus B square, therefore, mu f by 2 into R outer minus R internal, where R outer plus R internal divided by 2 will become mean radius of the collar. Therefore, the total frictional torque in case of uniform theory goes mu f into mean radius of the collar. Therefore, the torque transmitted is lower in uniform wear theory compared to the torque transmitted in case of uniform pressure when you make the comparison between these two terms. Then, based on the understanding what we have got it, we will try to attempt a problem that is inner and outer radii of a single plate clutch are 40 millimeters and 80 millimeters respectively. Derive the maximum, minimum and average pressure when the axial force is 3 kilonewtons. For that, the diagram expected to be like this. The clutch plate expected to be like this and the axial pressure is 3 kilonewtons and when it comes to R internal is equal to 40 millimeters and R outer is equal to 80 millimeters. Okay, the maximum pressure will be at the inner radius. Therefore, F is equal to 2 pi P internal into R internal into R naught minus Ri. So, F is given to us. Pi is the internal pressure, internal radius, and these are the outer minus internal. Therefore, as we given, the internal pressure is from the solution, it is 298.4 into 10 cube Newton per meter square, or we can say 298.4 kilonewtons per meter square. That is the maximum pressure. The minimum pressure will be at the outer radius. Therefore, 2 pi pi Ra R naught minus Ra. So here I am going to give at outer radius. This is P outer. This is P outer we need. Okay, that is the pressure we consider P outer, where we consider the, instead of 40, we are going to give 80 millimeters term here. 80 millimeters term here. Therefore, the minimum pressure is expected to be 149.2 kilonewtons per meter square. When you consider these two, more or less, the pressure at the inner radius is almost double to the pressure at the outer radius. Therefore, the pressure, but P into R is equal to constant. Hence, the average pressure is equal to total force by cross-sectional area as per uniform pressure theory. So, the average pressure is 198 point, that is 3000 by cross-sectional area is pi into outer radius minus square minus inner radius. Therefore, the point which I am trying to drive is more clear for you based on both uniform theory, uniform wear theory and uniform pressure theory. Further, a single plate clutch is required to transmit 8 kilowatt at 1000 rpm. The axial pressure is limited to 70 kilonewtons per meter square. The mean radius of the plate is 4.5 times the radial width of the frictional surface. If both the sides of the plate are effective, please make a note of it. If both the sides of the plate are effective, means our plate is like this and there is a clutch plate here. This is friction material. And this is the friction material. And this happens to be the pressure plates. And pressure will be acting like this. So here there is a contact. Here there is a contact. Here also there is a contact. Therefore, it is equal to 2 clutch plates because it is acting on both the sides. So, and the coefficient of friction is 0.25. Find the inner and outer radii of the plate. Therefore, we have to find out Ri and R outer. These are the solutions which you have to draw out. Width of the friction lining. Width of the friction lining. So, given that power is equal to 8 kilowatts and coefficient of friction is equal to 0.25. N is equal to 1000 rpm. And the relation has been given to us. And the relation has been given to us is mean diameter is equal to R naught plus R internal by 2, which is given as 4.5 times of the deviation between the outer to the inner. Therefore, equating these two terms, we get a relation between R outer to R internal. This is the relation which we are going to get it. In case of power transmission through a clutch, it is safer to use the expression obtained by uniform wear theory. In that case, maximum pressure is at the inner radius. Okay, that is what we So for clutches, we use uniform wear theory unless explicitly it has been expressed to use the uniform pressure theory. And the power transmission is given by P is equal to T into omega. Therefore, from power transmitted is 8 kilowatts, 8 into 1000, torque into 2, omega is equal to 2 pi n by 60. Therefore, T is obtained. Using uniform wear theory, we have got T is equal to mu f by 2 R outer plus R internal into where number of effective surfaces, as I have given in the diagram, where number of effective surfaces n is equal to 2. Therefore, mu by 2, 2 pi pi Ri, where we are getting maximum pressure at the inner surface, R naught minus Ri. This is with respect to F, R naught plus Ri into 2. Therefore, mu into 2 pi 70 into 10 cube Ri into R naught is 1.25 Ri minus Ri into 1.25 Ri plus Ri, where this 2 and 2 gets cancelled. Okay. Therefore, we have got an equation between these two. From here, the Ri is reduced as 0.1073, that is 107.3 millimeters. R outer and R inner, we have got a correlation as per the problem. The outer is 134.1 or 0.1341 meters. Therefore, R mean is equal to R naught minus Ri into 4.5. This is mean diameter. Then width also he has given as width is equal to R mean by 4.5 or 26.8 millimeters. Further, one more problem we will take it up. A single plate clutch transmits 25 kilowatts at 900 rpm. The maximum pressure intensity between the plates is 85 kilonewtons per meter square. The outer diameter of the plate is 360 mm. Both sides of the plate are effective and coefficient of friction is 0.25. Determine inner diameter of the plate and axial force to engage the clutch plate. Similar to the previous problem, this is the friction lining and these are the friction plates. Yeah, this is non-ferrous material, that's the reason friction plate. And this one and this one are supporting steel plates. And these two surfaces are effective, therefore n is equal to 2, a similar way. And the outer diameter is given as R outer is equal to 360 millimeters. Okay, outer diameter rather we can say. So 360 divided by 2. That is what we have to consider. Diameter is 360, R outer is 360 by 2. That is what we have to conclude. And P is equal to 25 kilowatts, mu is equal to 0.25, N is equal to 900 RPM, R outer is 0.18, and pressure at the between these plates is 85 kilonewtons per meter square. As you know, power is equal to T into omega. Therefore, torque transmitted is derived. Torque transmitted is derived. Then the torque transmitted is equated by using a uniform wear theory. Uniform wear theory, where n is equal to number of surfaces. Therefore, mu by 2 into 2 pi pi ri r naught minus r outer minus r inner into r outer plus r inner into n is equal to 2. Therefore, we have got the torque, and this is the 0.25 pi into this pressure value is 85,000 into Ri, and R outer is 0.18 meters minus R internal, R outer 0.18 into R internal, where 2 and 2 gets cancelled. Okay, therefore, a equation has been obtained in Ri, R internal. By solving it, we have got 131.5 millimeters. Therefore, the axial force that is required is reduced as 2 pi pi into Ri, and this is the value into number of surfaces 2, and this is going to be the value, that is the axial force that is required. Okay, further to this, we will go ahead with the multi-plate clutch. In a multi-plate clutch, the number of frictional linings and metal plates is increased, which increases the capacity of the clutch to transmit the torque. The figure shows simplified diagram of a multi-plate clutch. So earlier we have got only one clutch. Here we can say flywheel, and this is the disc plate, and this is the engine shaft, and this is the driven shaft, and there is a spring that keeps the friction rings and friction lining on the intact as a stack of the friction contact. These are the disc plates, and these are the friction rings. Okay, so with this, the number of the power transmitted will increase. The power transmitted will increase. Further to this, and the formulations is again based on the uh, uniform pressure and uniform wear itself. A multi-plate disc clutch transmits 30 kilowatts of power at 1800 rpm. It has 4 discs on the driving shaft and 3 discs on the driven shaft, providing 6 pairs of contact surface. The external and internal diameters of the contact surfaces are 200 and 100 mm respectively. Assuming the clutch to be new, find the total spring load pressing the plates together. Coefficient of friction is 0.3. Also determine the maximum power transmitted when the contact surfaces have worn by 0.4 millimeters. There are 8 springs, and the stiffness of each spring is 15 kilonewtons per meter. Here the diagram is friction linings and friction plates will be like this. Okay, and similarly, here you are going to have the friction linings, then steel plate, one more plate will be coming over here. So that is how the arrangement of these multi-disc will be taking place. Okay, here two friction plates and two contact, that is driver and driven. That is how we will be looking at. So where the speed of the shaft has been given 60 radians per second, that is omega. A new clutch has to be uniform pressure distribution. Please make a note of it. New clutches will be under uniform. After certain amount of period, they will be considered as the uniform wear. But after initial wear, the clutch exhibits a characteristic of uniform wear. This is most important. Power is equal to the total torque transmitted has been given. From this, what he is the solution is expecting is the torque transmitted is derived from this 2 by 3 mu f r outer cube minus r inner cube by r outer square minus r inner square into number of pairs, that is 6 has been given here. From this, the axial force is determined. The axial force that is required for the clutch to be engaged has been determined. When the surfaces are worn out, contact surface number of pairs of contact is equal to 12. The total wear is equal to number of surfaces into wear of each surface, 12 into 0.4 mm. Next, stiffness of each spring is 15 kilonewtons per meters, which is equal to 15 newtons per mm. Total stiffness of the spring is equal to, then as per the question, stiffness into number of springs, 120 kilonewtons per mm. Reduction in spring force is 120 into 4.8. Therefore, 576 newtons. New axial load is, originally we have got the 1137, because of the worn out, the force is reduced by 576 newtons. This is the new axial load. Therefore, once worn out, we consider this to be under uniform wear criteria. Therefore, T is equal to half mu F R outer plus R inner into number of pairs in contact. That gives half into 0.3 into 561 into 100 plus 50 into number of pairs is 66. Therefore, that gives the torque that is given. That is nothing but 75.735 Newton meters. And maximum power transmitted is equal to T into omega. That is 14.276 kilowatts. Under new, it can deliver a power of 30 kilowatts. After worn out, the power is reduced to 14.276 kilowatts. Therefore, under new condition, we are considering the clutch to be considered as under uniform pressure distribution. After worn out, it is to be considered under uniform wear. Please, this has to be noted while calculating any clutch. Then further, we are going to introduce the cone clutch. When you consider here, the under cone clutch, definitely the contact surface at this conical portion is increased. Therefore, the axial force will be improved to a great extent by having the cone clutch, and power transmission is improved for the same given design space. For the game design space. Therefore, even in the power transmission, we go with the V-belts and cone clutches, which will provide a better and higher contact surfaces, which will have more power transmission capability. In a cone clutch, the contact surfaces are in the form of cones. In the engaged position, the frictional surfaces of the two cones, A and B, are in complete contact due to spring pressure that keeps one cone pressed against the other all the time. When the clutch is engaged, the torque is transmitted from the driving shaft to the driven shaft through the flywheel and the friction cones. For disengaging the clutch, the cone B, this is the disengaging, pulled back through a lever system against the force of the spring. The advantage of cone clutch is that normal force on the contact surface is increased. If F is the axial force, Fn the normal force, and alpha is the semi-cone angle of the clutch, then for a conical collar with uniform wear theory, T is equal to, as we know that this is the normal force, is the normal force, and this is the axial force, and this is the semi-cone angle, Fn and F. Therefore, Fn is equal to F by sin alpha. Therefore, the normal force will be increased and more power transmission can be experienced. Therefore, here F by sin alpha half mu F by sin alpha R outer plus R inner. Therefore, mu Fn into sin alpha by sin alpha R naught plus Ri, that is mu Fn R mean, where Fn is equal to F by sin alpha. And we can also write this as F is equal to 2 pi PR R outer minus R inner by sin alpha. Therefore, sin alpha is equal to, if you consider here, this is the B, when you consider R outer, R inner, and this is the alpha, and this height is R naught minus Ri, and this is B. Sin alpha is equal to R naught minus Ri by B. Okay, this is how we are going to get the, where B is equal to, again a design width of the lining that we have to determine. This is the normal force and this is the axial force, and alpha is the cone angle. Okay, therefore 2 pi P R into B. What is this B? Where you can consider R naught by Ri by sin alpha. That is going to be your, this particular portion will become B. So this is how we are going to conduct the power transmission in case of a cone clutch. Further, the semi-cone angle of a cone clutch is 12.5 degrees and the contact surfaces have a mean diameter of 80 mm. Coefficient of friction is 0.32. What is the minimum torque required to produce slipping of the clutch for an axial force of 200 newtons? If the clutch is used to connect an electrical motor with a stationary flywheel, determine the time needed to attain full speed and energy loss during the slipping. Motor speed is 900 rpm and the moment of inertia of the flywheel is 0.4 kg square. And the solution gives mean diameter is 0.04 meters, coefficient of friction 0.3, F is 200 newtons, semi-cone angle is 12.5 degrees, RPM is 900 RPM, and moment of inertia is 0.4 kg square. And we know that the torque by theory, what we are giving, the other formula for this one, T is equal to I into alpha. where I is equal to moment of inertia, alpha is the angular acceleration. Therefore, equating our uniform theory torque transmitted to the torque equation, mu into F by sin alpha into R mean should be equal to I into alpha, and 0.32, and F is given as 200 sin 12.5 degrees into mean diameter is this. From this, we can find out the angular acceleration. Therefore, T is equal to 0.4 into 29.57. That is the torque transmitted. And the, whatever the time required is, again, we consider theta is equal to, here we consider the omega by T is equal to 29.57. Therefore, omega is equal to 2 pi n by 60 into time. That is equal to 29 point. This is where here it is omega by T is equal to alpha acceleration. Omega by T. Therefore, rate of change of angular velocity with respect to time, that is nothing but omega by T is equal to 29.57, where omega is 2 pi n by 60 into time is, which we have to determine, is equal to 29.57, which gives the acceleration is taking place within 3.187 seconds. During the slipping period, angle turned by the driving shaft is equal to theta is equal to omega into T. That is the formula in any given. Therefore, theta 1 is equal to omega into T, 2 pi n into 900 by 60 into time is given. That is 300.4 radians. Angle turned by the driven shaft, theta 2 is equal to, by physical applications, V2 is equal to, V is equal to ut plus half at square, with this formula, where this is can be applied to this formula. Theta 2 is equal to ut omega naught into t plus half alpha naught into t square. The initial value is 0. Initial time is 0, which we can consider. From this, the angle turned by the driven shaft is 150.2 radians. Energy lost is equal to T into theta 1 minus theta 2. This is R. Alternatively, we can, energy supplied is equal to T into omega into time. This is the energy supplied. Energy of the flywheel is half I omega square. This is the energy of the flywheel. And energy lost is equal to, this is the energy lost. Okay. So with this, we have also completed the tutorials of the single plate, multi-plate and cone clutch. And the referred textbook, more preferably S.S. Ratan and Belani, J.S. Rao and Dukipati and Shigley. These are the preferred books for the clutches and other domains. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.